Well, students, let's get started. We have another lesson tour today, and today we're going to be talking about the distance formula. Now, the distance formula says if A and B are points in a coordinate plane. Well, if we have points A and B, let's call this point A. And if we have the point B here, then the distance between A and B is given as follows. Now, think about what the distance would be. The distance would be an actual line or segment if we could draw between the two of them, such here. Now, we can only just put a ruler on that, but sometimes we don't always have rulers. So what do? Well, the formula where it says then the distance between A and B is as follows. AB would equal the following. If A had some standard point of x1, y1, and B had some point of x2, y2, then the formula would be x2 minus x1 squared plus y2 minus y1, it's a minus, all squared. And once we complete all that operation, we then take the square root of those values. So looking at these are two different numbers. Let's look at the following. If we have point C here, and let's say we have point D. So we have point C and D. We want to find the distance from point C to point D. So, first of all, we need to know what the coordinates are of C and D. Well, we can count in the coordinate plane. C has the coordinates of over 2 and down 2. So if we go over and down, so that is what? 2, negative 2. D has the following points of 1, 2, 3, 4, 5, 6. And then down 1, 2, 3, 4, 5. So it's a negative 5. So using those 2 points, we're going to plug it into the formula. So the value of CD, or the distance from C to D, would be equal to the square root of, using our formula, here's my x2 minus my x1 squared plus y2, and y2, oh my goodness gracious, should have erased, shouldn't I? My y2 is a negative 5 minus a negative 2. So notice that minus a negative becomes positive. And we complete the operation. 6 minus 2 is 4. We will then square it. Plus negative 5 plus 3 is a negative 3. I'm sorry, negative 5 plus 2 is a negative 3. Complete the operation. 4 squared is 16. Negative 3 squared is 9. If we add 16 plus 9 gives us 25, and the square root of 25 is 5. Therefore, the distance from point C to D, we recognize it as just the 2 letters of CD, is equal to 5. Distance formula. Let's look at one more example. So we have a new coordinate point, and we want to find the distance between the 2 points. We have point A, and let's say that we have point, let's say that B is right here. And we want to find the distance from A to B. Maybe it's better if you can see it. I like to have my lines drawn so I can see that. So if I'm looking at A to B, I want to know the distance from point A to point B. Well, first of all, we have to know the coordinate points. So the coordinate points of A would be 1, 2, 3, 4, negative 4, comma, 1, 2, 3, 4, 5. And point B would be at 1, 2, 3, 4, 5, 6, 7, 8. 0. Using those points in our distance formula, distance, we can say distance is equal to the square root. We'll call our formula as x2 minus x1 squared plus y2 minus y1 squared. Plugging in what we have. If it helps, maybe you need to call this x1 y1, x2 y2, and then start plugging in. Here's x2, so I have 8 minus a negative 4, so that becomes a positive, plus 0 minus 5. We're going to square, and then of course we have to take the square root. 8 plus 4 gives us 12. We're going to square it. 0 minus negative 5 is negative 5 squared. So we have what? 144 plus 25. Adding those two numbers together, we get 169. And the square root of 169 is 13. Therefore, the distance from point A to point B is 13 units. Now, let's look at this problem in a different way. Notice if we were to go vertical and from there go straight horizontal, notice what we form here. Indeed, we have a right triangle. And this is where the distance formula is derived. Notice we have the right triangle, and we could say that this side is A and this side is B, or vice versa. It does not matter here. And we're looking here at my hypotenuse as being C. And recall that C squared is equal to A squared plus B squared. Well, how do we get the A and the B? Well, it is the difference of the values. In this case, A is the difference of my Y values. So from A down, that's a difference of 5 squared. And my B values would be the difference here to here, which are my X values, and happens to be 12. Now we can look at it that way, or we can just say, hey, let's count. 1, 2, 3, 4, 5. It's 5 units long. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. And if we solve and complete, notice when we are solving, in order to get C by itself, what would I have to do? Take the square root of these values. And by doing those, notice the similarities here. The only thing difference is the reversal. But with addition, we have the community property, so it does not matter if I add 25 plus 144 or 144 plus 25. We will still get the solution of 169. And then therefore, the square root of 169 is indeed, once again, 13. So that's just how the distance formula relates to Pythagorean theorem. I hope that you have learned something today, and we can be able to apply these in the coming classes.